Okay, what we're gonna do this morning is this. I send you the copy of my lecture note, which is nothing really new, but the extract out from the Professor Du's chapter 7 content, and we're gonna do two things. One is maybe another 10 to 15 minutes lecture up to the page just before the example starts. Okay, then that complete complete note for the first order reliability method. Then after that, I want you to come out. Give a presentations or talk for the problem that I assigned to you. Okay, so that's what we're gonna do. Then next week, Monday, we're gonna start doing some example problem to really understand the procedures to compute. Two problems are two random variable problem, and last one is a 20 random variable problem. So from that point, to solve that problem, of course, the Professor Du didn't go through complete. It just shows the first couple steps. Then you should able to prepare like a MATLAB code to automate the procedure for FORM. Then we'll go on, okay? And I'll show you some other very nice approach. I mentioned to you last lecture, there are tons of different ways people just, this is better, this is better. The reason is people, they have to solve a multi-dimensional integration problem. There are a lot of different ways going from here to Seoul. At least 10 different ways I can go by driving up. It's the same situations arises. Okay, be careful on the 감기. 독감. You know what's a 독감, Arlene? 독감 is what do you call it? Severe cold. So Yesu was down for a day, but now she came back. It's good. All right. So the Wednesday, it's just a continuation from Wednesday. What we did for performance function in iteration mode, and we did, this is page 4-16 in my lecture note, which I sent you Wednesday. GUK plus GUK beta k plus 1 beta k minus k plus 1 equal to 0. Page 16, you can look at about the middle. So if you rewrite this, then recursive, one of the recursive, or you can say formula, is beta k plus GUK UK. So this is one of the very important equation you have to use in the iterative manner. So that's one equation. Then then you can say for updating the u, k plus 1 is equal to minus beta k plus 1. This is in previous page. We have the derivations and all that. So this equation, that equation is kind of a very important, which is equal to AK minus AK beta K back into here, G U K G U K. So this is a final. No more additional the equation forms to solve. The destination is really to solve the PF. PF is equal to, in this case, this is minus beta. Minus beta is reliability index, as you know. So overall computational procedure. Overall computational procedure, you must solve, of course, every time, every step, every case step, you have to go through the two equations. But from the beginning, at the beginning, you have to assume. So computational procedure, when we solve problem set 1 and 2, that's a two random variable situation, everything will be very clear. But even if I lose some of you here a little bit, so it's gonna all come back. And when you solve the third problem for 20 variable situation, then you have to program yourself as a group. Okay, we have a group of 3 members, so that's what we're gonna do that. So computational procedure, then you have to use recursive. Formula is what we developed. Nothing but this. So I'm going to put this guy right here. What's a beta? Beta is a norm, the distance between origin and MP point. Okay. So that's what the beta is. Every time you have to update beta because the lengths keep changing. We are looking for minimum lengths. So so beta is the norm of the u k plus 1. That's what is right here. And this is for beta k plus 1 right next here. Second equation is recursive. Formula is, which I just write here. Then at the beginning, you have to assume initially the u value, which is multidimensional, of course. If it's a two-dimensional, assume u naught at the beginning. If it's multidimensional, usually you can assume everything is 0. At the beginning, you have to pick someone, then keep iterate to get to the MP point, which is u star point. at the beginning assume that one. And then next step is, of course, you have to compute the beta, which is nothing but the length of that u. But initially, what's the beta value to be? When you assume this guy, initial trial value is equal to 0. This guy is 0, right? Length is none. Then first iteration start from the 0 and become 0. So this is page 18, 4-18, and assume u naught. Assume 0 or 0. Then you can compute, well, this is u at the beginning is equal to u naught. Then compute the beta. Just the first step is equal to 0, otherwise it's not 0. From the second step, is keep updating. At the beginning, it moved quite fast to u start point. Then after that, you compute the a. What's the a? What's the a means? What does it do? Q1. What the a? What does it mean, a? A is a unit vector, right? But a is a unit vector. This is a g function unit vector pointing outward direction, which is a vector. Outward direction from the z function, which is equal to like g, like a delta g u over delta g. This is a unit vector outward direction. That's what the gradient does. At the given point, this is like a u, could be k or k plus 1, whatever. Then the u vector is getting the from this is origin. So if this point is uk, this is kind of uk pointing. Then you divide by this guy as a uk, for example. Then this is gonna be the unit vector. This is unit vector again, and this guy is equal to this, but sign is different. So I have to put this direction. This is what minus a vector, unit vector, and this guy is equal to that guy. That's what it lead into the recursive formula to here. Okay, so a vector, next step is to compute this guy, delta g u norm delta g, this. You have to compute that. Once you compute that, then next step is a growth step, so we'll go, each iteration. So next one is a beta new update process, beta plus g u delta g u. This is exactly this update process. This is a k plus 1, this is beta k, getting into the next step. Then Then next step is U nu is equal to minus A beta. And now, when do you stop the iteration? That's the question. When do you stop the iteration? So, when do you stop? So this is if statements. If, like U nu minus U is less than equal to epsilon, some small value. If it's almost equal, which means it's a converging process, right? It's a convergence check. Then if it's less than equal, then stop. No more. Yes. Then stop. Otherwise, from here, you're going back to here, then keep iterate. And this criteria, a few different criteria, is really end up to be the same thing. The del G U max, U nu, minus, you can compare the gradient vector, or you can compare the U vector, or you can compare beta nu minus beta if it's less than equal to epsilon 3, then stop. Otherwise, go back to A, recalculate k plus 1, k plus 2, k plus 3, then stop. This is really a computational procedure, but if you solve about 3 pages starting page 419, then it should be very clear. Anybody solve first 2 problems? Example 1, example 2. Are you willing to solve first 2 problems over the weekend? No time? Arlene, did you try? Are you willing to try? Who cares? Okay, let's, I want you to solve first 2 problems. Then I'll go through together. Then 3rd problem I'll go through. Then that point I want to assign as project 1, term, not the term project. Maybe it may need a little bit time than just a couple of days to program that out. So as each group, because that's the beginning of the term project. A term project is not much different from example 3, because if you want to solve 20 random variable problem, then you can do very nicely for the term project. I told you I weight high for the term project. But I'm going to keep moving on into the a different method within the first order reliability method. Is called the mean value, the first order reliability method, which has very good merit in it. So that's what I'm going to do that. Then I'll talk about the second order, the reliability method. So I'm going to go back and forth on the one reference book to another. So that's what I'm gonna do. Okay, so I'll stop lecturing today here. Then I want you, with the next 30 minutes, you should be able to come out, give a talk. So it's now your turn to talk. Problem number 1. Who is responsible for problem number 1? Yonghyun? Okay. And second problem, Arlene, you heard I assigned you to solve problem number 2? No? Who? I think I assigned someone for problem number 2. Yes, sir? Problem number 3. Okay, problem number 2. Okay, Yonghyun. Songtae, I assigned something to you? Oh, yeah, you got the easiest one. What about Yesu is problem number 3. Who is willing to try out the problem number 2? Which is not complete solution, just a formulation, because you can't get the integration. So whoever ready, come out and start doing it. Yunsuk, you got number 3. You got number 3. You got number 2. That's just formulation. So would you all come out? Each board you can do 1, 2, 3. Then after you explain, then next 3 persons can come out and finish this up. Explain well, that's what I want to say. I have a reason why I assigned those people. Okay, problem number 1. Yonghyun, come out. So as I mentioned, the 8 out of 11 did not quite complete to get the right answer. So it's a good time to review.
This problem is actual stress is deterministic and yield stress is normal probability density. We already studied same case. Yield stress deterministic, actual stress has log normal. Process is very similar. Yield stress sigma y is 1 over sigma b sigma y root 3 pi exponential minus ln sigma a sigma y square over 2 b sigma y square. CDF is the equation, very similar. Natural log t minus a sigma y square over 2 b sigma y square equals z. This equation change this equation equal b ln sigma minus a sigma y over b sigma y. PF is probability of sigma y less than sigma s equal CDF sigma s F sigma y sigma s and P ln sigma s minus a sigma y over b sigma y. Reliability is 1 minus PF and equal 1 minus P natural log sigma s minus a sigma y over b sigma y. given sigma s is 35 kpsi and mean of is stress 50 kpsi and standard deviation equal 15 kpsi. B sigma y is root variance ln sigma y, and B sigma y and A sigma y learn already log normal density function, and solve the input that PF is 0.1423 and reliability and equal 0.8577. Number 3, central safety factor is N1 equal expected sigma y and over expected sigma s equal mu sigma y over sigma s equal 1.4286.
Okay, questions? Okay, if I give you this problem again, you feel you can complete with 101. Okay. Thank you. Okay. Next is
of this problem 2 is calculate probability of failure. In this case, actual stress and yield stress are both random variable, and actual stress follows normal distribution and yield stress follows normal distribution. So calculate the probability of failure. Define the PF. PF is equal to probability, which the yield stress is smaller than vector stress. And this is PF is equal to integral of f sigma y sigma s, which is jointly distributed. In this case, actual stress and yield stress are statically independent, so we can express f sigma y sigma s as f sigma y times f sigma s. By doing so, we can calculate the PF easily. PF is equal to double integral of f sigma y times f sigma s, and this part is equal to f large f sigma y. So we can express it as this one. So just substitute this one and this one as a log normal distributed function and normal distributed function, normal density function, and normal density function, cumulative density function. So it becomes this one. So state the expression using probability density function and cumulative density function. And in this case, A sigma y, B sigma y is mean and standard deviation of ln sigma y, and mu sigma s, B sigma s is also mean and standard deviation of sigma s.
Okay, question. Okay.
Problem number 3 is get the probability density function of y. The x is random variable and the x is normal probability density function. And there are some relation between y and x like this. As you know, you can get the probability density function of y using the probability density function of x. And when you get the x value, there are two values. First one is plus sign and minus sign. So I x1 is a plus sign and x2 is a minus sign. Then fx is normal probability density function, and that is like this. So we can get probability density function of y like this.
Okay. Question.
Question.
Okay, thanks.
Okay, thanks.
Next.
Okay, let me explain about the problem. The first question is what value of the C? As you can see in your exam paper, the C is just a random, just a certain variable. When you're thinking about the CDF, the graph, we easily correct it into what value should be. So when you integrate the PDF combination, and we can get the, you should be able to get the one. So conversely, we inversely we calculate this combination. Finally, we get the value of the numbers, the value of the C, 1/36,000. The question B is explain about the PDF and CDF of explain about the CDF of PDF function. As I mentioned in the number 1 question, when we integrate a certain area 0 to 60, the area of the CDF function should be 1. So between the 0 to 60, the CDF formulation should follow this formulation, and when the range is over the 60, the value should be the 1. And smaller than 0, there is no value, so the answer is 0. The question C is when is the does not exceed the 80% of monthly expense. Using the maybe you easily understand this formulation. Between the 0 to 30, the percent of the CDF is 50%. For the $4 is 74%. But when we using the $50, the probability is over 80%. So the answer is $30 and $40. the question D is the mean value of the monthly expense for 2 person. If you easily do the this formulation, so we just multiply the X value in front of the PDF. So finally you can get the $30.
It should be the two-person totally missed it, and 9 people did almost all right. Okay, thanks. And this is about time to finish. But I want to see number 6. Rather than number 5. Number 5, almost everybody did well. But still, couple people, one person had a hard time. But the last problem is interesting, and I want to go out finish itself so quickly. It's not much time. Mr. Nam is going to take another couple of minutes. Okay.
This is a very simple problem. Just we have to find the probability for intersection of event A and B. This one is event A is an even number so event A is we describe this, and event B is a number divided by 3 comes, so event B is 3 and 6, and so intersection event A and B is just 6, so probability event intersection A and event is just 1 over 6, and number 2 problem is same problem. Event A is even number, same 2 over 6, and event B is the prime number, so just 2, 3, 5, and the probability A intersection A and B is just 6, just 2. And problem 6b is also saying we have to find the probability of events intersection event A and B. This is described with this equation. Intersection of event A and B describe this equation by using a conditional probability. But if 2 events is independent, this equation like that, because there is no relationship. So just event probability A times event probability times event probability event B. So just like that.
This kind of the problem is called bonus problem. Okay, so I'll see you Monday. But problem number 5, I assigned to Jin-gyun, but not enough time, so I want you to review problem number 5. Okay, we'll see you Monday.